Hi, everyone. So this will be our final lecture. We're going to just talk a little bit about how you use Bayes' theorem. And then from there, you'll just have the 10th quiz to take. And then after that, you'll be officially done with the course. So thanks for hanging in there. I'm glad to see many of you are doing a good job. Most of you are doing a good job of keeping up with your quizzes. So yeah, this last lecture will be about Bayes' theorem and how to use Bayes' theorem. So recall that this equation here is Bayes' theorem, right? So Bayes' theorem just tells us gives us a measure of the degree to which a piece of evidence supports a hypothesis. And so when we're thinking about the relationship between premises and conclusions, what we're really doing is just thinking about the relationship between evidence and a hypothesis, at least in terms of Bayes' theorem. So what this ratio allows us to do is it allows us to capture sort of the strength of an inductive argument by showing how likely it is that a hypothesis will be true on the basis of the evidence. And so this can be used to model inductive reasoning. So I'm going to try to make this one quick. What we're going to do is we're just going to kind of run through and talk about how to use Bayes' theorem. I'll show you this slide real quick, and then I will go through a couple of exercises so that you can get a feel for how it should all work. So there are roughly 4 things you need to ask yourself as you examine problems related to Bayes' theorem. The first is when you're reading a problem, ask yourself what the hypothesis is. What's the main thing that's being supported? What's the evidence? What's the conclusion that we're concerned with? So in many cases, this can be kind of tricky, actually, and so you'll want to think carefully about it. In turn, you'll also want to think about what the evidence is that's being used to support the hypothesis. So what's the observation here? What is being drawn on to try to support some further claim? Third, after you've identified the hypothesis and the evidence, you want to construct a key and you'll assign a letter for each, the hypothesis and the evidence, and you'll construct a key where the key gives us an interpretation of what those letters mean in the context of the problem. When you're completing your quizzes and everything, you should make sure that you include that. That's a really important component of all of this. So fourth, then you'll formulate the conditional probability that you need to solve the problem. So in this case, I have it represented as the probability of the letter representing the hypothesis if we assume the letter that we're using to represent the evidence. So for example, if we have, we can take the form of Bayes' theorem after we do that. If we use O and B, then we're treating O as the hypothesis and B as the evidence. We know that we would know that this is the ratio that records the degree to which the observation B supports O. So sorry, that says P, it should be B, but anyways, so after that, you would find, given the problem that you have stated, you would try to fill in the numbers for each of these parts of the ratio and then just run through the calculation, right? So this requires no more than basic division, addition, and multiplication. And so you should find that the hardest part should be just uncovering what the right way to calculate this is. So let's take a look at some of the problems. I'm going to get out of this, and actually I'm going to copy and paste this so that I can reuse it as we go through some of the exercises. So here are some exercises. So let's look at the first one. It says Shane conducted a survey of his friends. The results showed that 60% own a video game console and 40% own a laptop computer. But interestingly, none of his friends own both items. He also found that 20% of the video game console owners have Twitter accounts, but that 70% of the laptop owners have Twitter accounts. What is the probability that if someone has a Twitter account, they own a laptop? Right, so in this case, to be able to identify the relevant probability, you're going to have to think pretty carefully about exactly what it is that we're looking for the probability of. Always begin here with the conditional probability. We need to figure out what our key is going to be and how we're going to define the letters in that key so that we know exactly what it is that we're hunting for. We're hunting for the probability of. In this case, the important piece of information that comes up is right here at the end where this question occurs. So it says, what is the probability that if someone has a Twitter account, they own a laptop? Well, thinking about the way our symbols are supposed to work, the interpretation of the symbols that we're using in our in the probability calculus, this little bar here means if, right? So we know that whatever, so if we're looking at the structure of this, we know that what we're saying is that if someone has a Twitter account, what's the probability that they own a laptop? In this case, then the hypothesis would be that they own a laptop. I'm going to change the letters here just so that it's a little more intuitive. And if they have a Twitter account, right? So the probability, what we're interested in here is acquiring the probability of somebody's owning a laptop if they have a Twitter account. So try to do your best to think about this in terms of evidence and hypotheses. We're making a particular observation, which is that somebody owns a Twitter account, and their owning a Twitter account is supposed to, in some way, given the way the problem is specified, give us evidence for the claim that they own a laptop. Okay, and so the question is, how much evidence is it? How good is the evidence that somebody owns, somebody has a Twitter account? How good is it as evidence for the hypothesis that they own a laptop? And so Bayes' theorem will allow us to do that. I'm not going to run through the exact calculation, but I want to show you how you would plug in the variables here. So first things first, we have laptop owners and we have Twitter account owners, and we need to make sure that everything in our version of Bayes, in our specification of Bayes' theorem works, right? So this is going to be the probability of T given L multiplied by the probability of T, so T given L by the probability of T right, and the probability of T given not L, probability of not L. Right, so in this case then, once we have, I'm sorry, this should be the probability of L. Small mistake. Anyway, once we have this equation in place, then what we need to be able to do is see where in the problem we can find the values that we need to plug in for each of the terms that occur in the ratio. So what that means is that we need a value for the probability of somebody's owning a laptop. We need a value for the probability that somebody has a Twitter account if they own a laptop. And then we also need the probability of somebody's having a Twitter account if they do not own a laptop, and the probability of somebody's not owning a laptop. And so finding each of these values requires a little bit of insight into what the problem is saying and exactly what the setup of the problem is. So for all intents and purposes, nothing outside there, like all the information that we're being provided is all the information there is. And that is all the information in the problem is all the information we're going to assume. So in this case, we know that there are 60% of people who own video game consoles, and we have 40% own a laptop computer. So realize that the relevant population here is Shane's friends, or the friends that Shane's friends who have been surveyed by Shane. And notice that you either own a video game console or you own a laptop. You don't own both according to this problem. So all of his friends either own video game consoles or they own laptops. Okay, so he found that 20% of video game owners have Twitter accounts, but that 70% of laptop owners have Twitter accounts. So that's where we're going to get some of these values here for these conditional probabilities. But first, let's focus on how we would fill in the variables for these other probabilities. So probability of L of owning a laptop is just going to be 0.4, and that's going to be multiplied by the probability of having a Twitter account if you have a laptop. So we have 20% of video game console owners have Twitter accounts, but 70% of laptop owners have Twitter accounts. So in this case, this is the relevant one here, right? Because we want to know the probability that you have a Twitter account if you have a laptop. Well, if you have a Twitter account here, then you have a laptop. That's 70% of the population. So you just plug in 0.7, right? And then obviously the left-hand side of the sum here is the same as the numerator. So we're just going to go ahead and do this, right? So, and then this is sort of the next hard part. You need to figure out what the probability of having a Twitter account if you do not own a laptop is. And notice that we don't directly state that nobody owns a laptop. And so you have to think about what it means to not own a laptop in this case. Recall that the population that we're examining is Shane's friends, or the friends that Shane has surveyed. And in that population, you either own a laptop or a video game console. So in this case, to not own a laptop is just to own a video game console. Right. So as long as we can assume, based on the way the problem is stated, the population can be divided in that way, then we're perfectly fine. In this case, then, the probability of not having a laptop is going to be equal to the probability of having a video game console, and that's going to be 0.6. All right. And now we need to know the probability of having a Twitter account if you do not own a laptop, or if you own a video game console. And that's going to be 20%. Right? So in this case, then, you take each of these and you just do the math. There we go, 0.28 and point plus 0.12. I need a calculator sometimes too, so let me make sure I'm doing things correctly. I'm sure they are. I'm just not very confident in my math. Okay, so we have then 0.28 divided by 0.28 plus 0.12, which in turn is equal to 0.28 divided by 0.4 and 0.28 divided by 4, or sorry, 0.28 divided by 0.4 is 0.7. So it's actually pretty good evidence in this case, or at least we're going to say that the argument that if somebody has a Twitter account, then they own a laptop, that the evidence in favor of that is actually quite good. That is, the observation that somebody has a Twitter account, that if somebody has a Twitter account, they own a laptop, is a strong inference. That is, the observation that somebody has a Twitter account does make it very likely, given this background information, that they own a laptop. And so this is the general way you would do this. You want to make sure that you identify what serves as the relevant observation, what serves as the hypothesis, plug in the relevant letters for each of those, churn out the form that Bayes' theorem has for each of those letters, then hunt down the values for each of the terms that appear in the ratio, and then just run through the calculation. And if you get, say, above 0.5, 0.51 or higher, then we would say that we would go ahead and infer that the argument is a strong one. If you get less than that, we'll infer that it's a weak one. So that's all there is to it. The hard part, again, is just making sure you know what it is that you're trying to calculate. Because if you get this wrong, then you're going to have a hard time finding the values to plug in. And so you want to make sure you have the interpretation as correct as you can get it. A really important part of this is making sure that we know what's functioning as the evidence, what's functioning as the hypothesis. And I'm going to keep an eye out for it to see that you're picking out the right relationship. So the relationship of, say, in this case, L and T, as indicated by the bar symbol here, that's actually, it's going to feel nitpicky, but that's actually a point that I think is important, because I need to see that you're actually identifying what's functioning as the evidence and what's functioning as the conclusion. So your key should be clear. I haven't specified the key here, but you should make sure that you specify the key. So in this case, we have L and T, in this case, like owns a laptop, has a Twitter account, right? So in this case, then that's what I would, this is sort of maybe what an answer would look like. I would just encourage you to copy and paste a written version of Bayes' theorem that you can just then adjust the letters for. And I want to make sure that you go through this very stepwise procedure, right? We have the variables L and T, and we have one that's serving as evidence, one that's serving as a hypothesis. That needs to be expressed in the equation that you're using, and then you need to hunt down the values for the corresponding pieces of background information. And so a broader lesson about this is just the way that induction works. It works by drawing on background information that we know about the relevant probabilities. And that's really an important insight. This stuff doesn't happen in a vacuum. This is why earlier in some of the earlier lectures, we talked about the principle of total evidence. The principle of total evidence is saying, use the relevant evidence that we all have as background knowledge that we share. And in this case, the shared information is the information stated in the problem. And so we can try to come to conclusions about the strength of arguments by drawing on that background information and drawing on fairly precise background information. So we might do research on things like, so for example, some of this stuff could be useful for calculating the rates of false positives or false negatives, or true positives and true negatives in tests. And so we can get a pretty accurate measure of how good, say, getting a positive result is on a test for supporting the conclusion that you should be diagnosed with a particular illness, like coronavirus or something. So these tools are actually pretty useful, and they're important for understanding how it is that we can try to find how we can support hypotheses in a pretty simple way. And as you practice with this, you'll probably start to find it a bit easier to digest and a bit simpler to understand. And so but the main thing for the purposes of what we're doing this last week is that you just need to go through and make sure that you're identifying correctly what the evidence and hypothesis is, hunt down the terms, and then perform the relevant calculations. Some of the exercises might ask you to say whether it's strong or weak. Remember that the 0.51 or higher is going to count as strong, 0.5 or lower is going to count as weak. Rounded to the nearest value as well. That'll be something that you want to make sure that you do, is that you're rounding it, because we don't need a full string of decimals associated with any given answer. But anyway, that's that. That's the final portion of this course. The quiz will be about some of these issues related to Bayes' theorem. You'll have to solve some of these Bayes problems, and I might ask you about stuff from earlier on in the lectures as well. But yeah, let me know if you have any questions, and otherwise we're done for today.